Hello, programmers. Dan McElroy here with a discussion on how Java uses the char character data type for printable and non-printable characters. Topics covered in this presentation are the character data type, char, character literals, variables, ASCII versus Unicode, the character class, character comparison methods, casting between int and char. In C, C++, and Java, char is a primitive data type for defining and using individual characters. Char is the name of the character data type. In this discussion, I will use char and character interchangeably. The word primitive, when referring to data types, means that it is built in as part of the language. To declare a character data type named answer, char, answer, semicolon, where char is the data type and answer is the name of the variable. By using char answer semicolon, Java sets aside enough memory space in RAM to hold one character and gives this space in memory the name answer, so that this space in memory can be referenced to by the name answer while the program is running. A character can be placed in this memory location by using the name of the variable, the equal sign assignment operator, and a character literal such as answer equals single quote y, single quote, semicolon. It is important to use single quotes, single quote y, single quote, to define a character literal as opposed to double quote y, double quote, which would define a string literal. The variable can also be declared and initialized at the same time. Char answer equals single quote y, single quote, semicolon. Constants are like variables, but their data can't be changed while the program is running. For example, use the pound defined in the C language with no semicolon at the end. Newer C compilers can also use the const declaration, like what C++ is doing. In C++, use the const modifier in front of the char declaration and use a semicolon. In Java, use the final modifier. Once a value has been placed in answer, it cannot be changed. It is common programming practice to use only uppercase letters and the underscore when naming constants. In this Java code, I can tell that string username declaration is using the object-oriented programming, or OOP, string class because the word string starts with an uppercase letter. Objects and variables should start with a lowercase letter in Java. What I find interesting between C++ and Java is that the word string for the class declaration starts with an uppercase letter in Java, but with a lowercase letter in C++. So, if you are studying C++, think of string starting with a lowercase letter. Therefore, string username declares username as an object of the class string with enough space in RAM to hold all of the data for the object. The first example, string username semicolon, creates an uninitialized object named username. It can't be used until it is initialized with some data. The second example, string username equal double quote Dan space McElroy double quote semicolon, creates an object named username and sets aside enough memory to hold 11 characters for Dan McElroy. The third example, string username equals double quote D double quote semicolon, creates an object named username and sets aside enough memory to hold only one character for the letter D. The fourth example, string username equals double quote semicolon, creates an object named username but initializes its size to 0 bytes. This is called a null string. Strings are covered in more details in a different presentation. Except for the IBM mainframes, most early computer systems used a teletype as the console input-output device. The teletype had a keyboard and a printer, and an optional paper tape reader and punch. The paper tapes were organized as rows of 7 possible holes for each character. It was considered as a 0 if the hole was not punched, and a 1 if the hole was punched. With 7 ones or zeros, this gave 128 combinations ranging from 0 to 127. The codes for teletype characters became known as the American Standard Code for Information Interchange, or by its more common acronym, ASCII. The ASCII character set is used for writing programs, names of files on disk, and when creating web pages. Although the IBM personal computers use ASCII, most IBM mainframe computers use a modification of punched card codes instead of punched paper tapes. The character set is known as the Extended Binary Coded Decimal Interchange Code, or ASCII for short. It is typically used only on IBM mainframes and has a very limited use anywhere else. ASCII uses 8 bits to encode all of the alphanumeric characters and punctuation, similar to ASCII, but each of the binary codes is different from ASCII. I won't be covering any more about ASCII since we won't be using it in class, but you should know it exists. If you end up working on an IBM mainframe, you may need to become familiar with ASCII at that time. Here is a full ASCII character set of 128 codes and their equivalent binary representation in hexadecimal, octal, and decimal. The chart has 4 columns. The first column of decimal codes from 0 to 31 are non-printing control codes. Column 2 has codes for many punctuation characters and the digits 0 through 9. Column 3 has codes for the space character, uppercase A through Z, and some additional characters. Column 4 has codes for lowercase characters, A through Z, and additional characters. Here, binary code, the letter A equals 1000001 using 7 bits. Since RAM is organized into bytes with 8 bits, it is usually written with the leading 0. A equals 01000001. This is the exact binary code as a decimal 65 because 1 is in the 64-bit position and a 1 is in the 1-bit position. When the bits are organized into groups of 3 bits for octal, it becomes 01000001 or octal 101. When organized into groups of 4 bits for hexadecimal, it becomes 01000001 or hex 41. This is done by giving a value for each group of 4 bits as 8421. The computer hardware only keeps track of the individual bits. It is up to the software on how these bits are interpreted. If we define a variable as a character, char result equals quote a quote, the 01000001 in memory would be treated as a letter A. If we define the variable as an integer, the int result would be 65. The exact same bit pattern would be saved in memory, but would be treated by the software as a numeric value of 65. The use of hexadecimal to represent bit patterns that represent characters is very common. You will see it many times in disk dumps, and even when non-alphanumeric characters appear in the URL of a web page. You may see the % sign and a couple of numbers in the URL of a web page address at the top of your browser. For example, the space character in the file name, quote, final space exam.gif, quote, is represented in hexadecimal as %20, where 20 is the hexadecimal code for the ASCII space character. Several of the control characters can be inserted into a Java program using what is called an escape sequence. The / character and an additional character are used to define a control character such as \n to represent new line. The \t tab can be used to line up columns by moving the cursor to the next 8th position. / single quote, / double quote, and / are used to insert the single quote, the double quote, or / as a character in a string. I realize that a single tick mark is called an apostrophe, such as the dog's bark is loud, but I'm referring to it as a single quote when coding. Watch out. You should not have a problem entering the single quote or double quote when using a pure text editor or an IDE when entering code. However, Office applications such as Microsoft Word, PowerPoint, or others like to use cool versions that tilt one way at the beginning of a quoted text and tilt the other way at the end of quoted text. Since the backslash is already used as the escape character and the quotes define the beginning and ending of a character or string of literals, we need to use the backslash followed by a single quote, double quote, or backslash to get one of these characters into a character or string literal. This is especially important when using a quoted string literal inside a program to specify a Microsoft DOS or Windows path and file name. Inside the program, string, file name, equal, double quote, backslash, backslash, Java, backslash, backslash, paychecklabreport.pdf, double quote, semicolon, becomes, backslash, Java, backslash, paychecklabreport.pdf. Because the double backslashes inside the string convert to a single backslash. To get a string literal, I asked Bill, what time is it? The string literal needs to be coded. I asked Bill, backslash, quote, what time is it? Question mark, backslash, quote, quote. The backslash quote puts a double quote in the string. Look at the end of the string. The backslash quote puts the double quote at the end of the string, and the final quote ends the coding for the string literal. We have another problem with Microsoft Win-DOS operating systems. Unix uses the dash character for command line flags and the / to specify a full path name and file name. Just to be different, Microsoft DOS 1.0 chose to use the / character for command line flags. DOS 1.0 didn't have subdirectories. This was fine until DOS 2.0 came out with directories and subdirectories, also known as folders. So they used the / character for the full file name because the / was already in use. At first, this incompatibility was not a problem. Unix and DOS didn't talk to each other. The C programming language was created in 1972 and 1973 for updating the Unix operating system. As universities started teaching computer science and operating systems, the C language became popular and the World Wide Web was released to the public in 1993. Since most web servers run on a form of Unix, the / is used in the Uniform Resource Locator, but Microsoft Win-DOS was already using the / for something else. Windows finally came around to accepting either the / or backslash in the path name. You just need to remember to use the double backslash, backslash, to get a single backslash, or backslash quote to get a double quote, or backslash single quote to get a single quote inside a Java, C, or C++ string. Columns 2, 3, and 4 have the printable characters for 0 through 9, uppercase A through Z, and lowercase a through Z. What is important to remember is that the printable 0 in binary is 00110000, or hex 0x30, decimal 48, but not all zeros. The printable 7 is 00110111, not 00000111, which is the bell. Uppercase A through Z go from hex 0x41 through hex 0x5a, and the lowercase a through Z go from hex 0x61 to 0x7a. If we look at the binary representation for uppercase A, it is 01000001, and the lowercase a is 01100001. There's only one bit difference. If you already know that the ASCII character is a letter, you can examine the 0x00100000 bit to determine if the character is uppercase or lowercase. This way to determine uppercase and lowercase works great for ASCII characters, but we will soon see that ASCII isn't only great for English characters. The remaining printable characters are either punctuation or other miscellaneous characters. Let's try converting bit patterns into ASCII characters. The example here has bits grouped into 8 bits each, which is a byte. to make things easier, separate each byte into groups of 4 bits, which then convert into a hexadecimal character. For example, if you had a bit stream that starts off as 01001000, first convert that into hexadecimal 48 by taking the first 4 bits, 0100, which become 4, and then the next 4 bits, 1000, which become an 8. Look up the hex 48 in the ASCII chart, which then becomes the code for the uppercase H. 0110 0101 becomes hex 65, which represents a lowercase e. 0110 1100 becomes hex 6c, which represents a lowercase l. The same bit pattern repeats for a second lowercase l. The 0110 1111 becomes hex 6f, which represents the lowercase o. We have the binary codes for the word hello. This is a two-way conversion. You can also convert the uppercase H into either hex 48 entered in code as 0x48. Since the ASCII character set uses only 7 bits stored in a byte, there are only 128 combinations of characters. This was fine for the English language, but computers begin to be used in many other human languages with many other characters and emojis. Unicode defines 3 encodings: UTF-8, UTF-16, and UTF-32. UTF stands for Unicode Transformation Format. Java uses 2 bytes for the character data type and Unicode character data type. However, most text files with the .txt file extension store characters in ASCII. HTML is used for web pages and uses the ASCII character set. See https://en.wikipedia.org/wiki/Unicode for a lot more information on Unicode. The Java language has several built-in primitive data types, such as int, long, float, double, boolean, and character. These data types are built into the Java language, but do not have methods or functions or subroutines to manipulate the data. Because Java is totally object-oriented, it can't have standalone methods or functions that are not part of a class definition. Therefore, Java provides the character class that has many methods available for testing or manipulating character data. In this code snippet, a variable named ch is declared as a character and initialized to the letter k. The character isLetter method tests ch and returns a true if ch is an uppercase A through Z or lowercase a through z. Otherwise, it returns false. The if statement passes because ch is a letter and the else statement is not executed. See more at https://www.geeks4geeks.org/character-class-java/. Placing character dot with the dot as part of the character dot isLetter open close parentheses states that the program will be using the isLetter method from the character class. This would need to be done each time any of the methods from the character class would be used. To save a lot of typing, just place the import java.lang.character statement at the top of the Java code file, and then you can skip putting character dot in front of each character class method that you will be using. Each of these character class methods returns a Boolean true or false depending on the test result. The isLetter method is defined as a Boolean isLetter inside parentheses char ch. Boolean is the return data type. isLetter returns a true or false that can be used in an if or while statement. Inside the parentheses is char ch. This identifies the data type that is passed into the isLetter method. What is important here is that the data type being passed is character, char. You can use any name for your variable or even a character literal. You can even pass a numeric value for a character such as hex 0x41 or decimal 65 for the letter A. IsLetter returns true if it receives an uppercase or lowercase, capital A through Z or lowercase a through Z. Is uppercase, is lowercase, and is digit should be easy to figure out. Is whitespace returns a true if it receives a whitespace character such as a space, a tab, a new line, or a return. Here's some sample code that uses the character methods to test a character placed into a variable named ch. If ch is a letter, A through Z or small a through Z, the program displays a message that it is a letter. Then, the next if statement identifies if it is uppercase or lowercase. The following else if statement checks to see if it is a digit 0 through 9. The next else if statement checks for whitespace. The final else gives up and says that ch is neither alphanumeric or a whitespace character. Here is the output for the program when ch is in capital A, small b, a 4, a space, or ampersand. The ampersand is neither a letter, digit, or whitespace character. Instead of using the character.isLetter method, you could test to see if ch goes from uppercase A to lowercase z, or goes from lowercase a to lowercase z. The way it is coded here works because the order of operations has the ampersand logical AND occurs before the logical OR, two vertical bars. Although this other method works fine for ASCII letters, there are a lot of other letters, especially letters with accent marks within the Unicode character set, that won't be tested using the second way. The character class also has several methods that can be used to modify a character. The toUpperCase method will convert a lowercase letter to its uppercase equivalent. If the character is already uppercase, then it returns the original character. The toLowercase method converts an uppercase letter to lowercase. The toString method creates a string with only one character in it, which is the character passed to the method. I also listed character at, char, capital A-T method, which is actually a method that belongs to the string class. It can be used to extract a single character from a string. The index starts at 0 for the first character in the string. Geeks for Geeks lists 86 character class methods that can be used when working with Unicode characters, comparing characters and several other methods. I recommend looking over the list of character methods provided by Geeks for Geeks website, even only if to let you know that they are there in case you may need them in the future. Here's a link to Geeks for Geeks. https://www.geeks4geeks.org/character-class-java/char letter A equals single quote A single quote semicolon. The decimal value for letter A equals 65. Int x equals open parentheses int close parentheses letter A semicolon. Cast character A to an integer 65. System.out.println open parentheses character A equals quote plus x displays 65. Int y equals 75 semicolon. Character ch equals open parentheses char close parentheses y. The comment / ch equals single quote k converted from ASCII 75. System.out.println 75 equal character quote plus ch. See you next time. Dan Dolph signing off for now.